This is the subject for this evening. When we talk about carbon targets, very often we're talking about energy in use, but this session is going to be on natural building materials and how they can contribute to our carbon targets, particularly when we're looking at embodied energy. And the speaker we have tonight, Thomas Robertson, he's going to introduce himself, but he's the MD of Adaptavate, and he's got some really interesting products that he's developing.
Yeah, thanks, Lucy, for the really kind introduction. It's really lovely to be invited by Green Register. A lot of people we come across in the industry speak really highly of the work you do in training, both with contractors and with the likes of who we have on the call today. And it's a really valuable part of raising awareness and knowledge within our industry. So it's really lovely to be part of it. I know the event is also sponsored by Eco Merchant, who we are distributed through, and Eco Merchant have believed in us since day one. So I think in terms of small company trying to make a big difference, it's great to be able to be supported by people like you guys. Yeah. Caveat. I've come to put this presentation on the screen, and I don't know if anyone can see, but there's all these little kind of X's here all over. So this was only found about 5 minutes ago. So that's a bigger problem on some of the slides because it's the whole slide. And on most of the slides, it's okay. So there might be a bit of ad-libbing going on here, guys, but I'll endeavour through the presentation to try and, bring what I was going to say to life. And I'll also try and solve this. And then you should be able to get a set of slides with some information.
Don't worry, Tom, okay. Ad-lib is fine. Thank you.
As long as it's not factually correct or incorrect, or it need to be. So I'm founder of Adaptavate. There's a great team that sits behind me. I'm just kind of standing up here today as the MD and founder. But our work is founded in material science, going into building and construction products and systems. I founded the business having been a builder, plaster and stonemason, working in Derbyshire, and I then went and did a master's in sustainable architecture, an MSc in sustainable architecture at CAT, and I have lectured there as Jeff, our technical director. So I'm sure there'll be Catters on here somewhere. There always is. We're a multi-award winning business and founder. I've kind of funded this business for the first few years, winning a bunch of awards, which helped on the dilution front, but not on the cash flow peaks and troughs. We won a place on one of the kind of countries, if not Europe's, most kind of recognized clean tech, climate tech accelerators, facilitated through Imperial. Won an entrepreneur award, and recently we've just been recognized as one of the UK's top 50 carbon scale-ups by PwC. They took 3,000 companies and narrowed it down to 50, and that's Adaptavate got featured on there. We've been supported by UKRI, Innovate UK. I'm sure people have come across them. Inevitably, the BRE, they will have done us also. And we're an accredited member of the FIS. So, yeah, that's a little bit about me and the team and whatnot. First off, what I really wanted to do was just like zoom in on what construction materials are today. Conventional materials. Let's start from that place. They're cheap. There's a race to the bottom. Basically, it's all about how cheap can we make them. They typically off-gas pollutants into the internal environment. They're made with a short lifespan in mind. They're not really engineered for durability necessarily, or a long, buildings of old have been designed for hundreds of years. These buildings now have been built for 10 years, tens of years. The material flows and companies that typically operate them and operate very vertically integrated business models and material flows, very linear take, make, waste material flows, and where the material goes away and where is away and what does it look like landfills are filling up. Conventional construction materials rarely consider the holistic balance of building. They're certainly not breathable. There's not really fabric first approach. And really, you know, capitalist structures and construction as being part of it is really around with the mindset of ecological extraction for the purpose of economical profit. And so what I found at Adaptavate to do was to kind of fundamentally rethink this, but to be able to have products that are suitable for the mainstream market all over the world. And so our mentality is around designing material flows that aren't linear, that are circular and regenerative, most importantly. That's ecologically and economically regenerative. And move away from traditional finite resources to annually renewable carbon capture feedstocks, to make products that are high performing, that are good for our buildings, good for our health, and good for our environment. We're really leading this transition to the future of carbon negative building materials that anyone can put on their walls for the mainstream market. So I'm going to talk a little bit more about our approach throughout that, but that's a little bit of a snapshot there, okay? What I'm going to go through here with various number of slides, if I do have them, is a bit of background and context. I'm not going to preach to you about what CO2 is and what the problem is that we find ourselves in, because you're probably all on the call because you're a little bit concerned about that anyhow. But I do just want to kind of emphasize some top line macro dynamics that I think underpin where we should be going as an industry. And the built environment's role in that, and Adaptavate's vision and action on that. And then we're going to kind of break that down into a few elements: carbon and built environment, natural materials and how they can help. Is it all about carbon? And then how we can take these natural materials into the mainstream, and some conclusions. So what really gives me the right to be standing up here talking to you? Well, I guess I used to be on the left. I'm a dirtbag really at heart. I basically spent 3 years living in a van, traveling around America and Canada and New Zealand and South America, kind of not wanting to be part of a capitalist society, certainly not being a managing director. I then went into natural building, and as a practitioner, as a plasterer, as a stonemason, I really saw the benefits of these things. I became interested about how the principles of that approach could be made more accessible to a mainstream market, and started to imagine the impact that could have if we could enable a transition. And really, therefore, Adaptavate, I've spent the last 7 years as the MD and founder of Adaptavate, but kind of 3 or 4 years before that, working, studying on my masters, etc., to be able to really understand systemically how we can make this transition. And most importantly, not to the detriment of ecological balance. And so really, this is not right, what I'm about to say. Some of it's founded in science, some of it's founded in policy, some of it other people have said, and I'm just kind of assembling it all in one partly illustrated, but not wholly illustrated presentation. And I hope that this presents a discussion. So I'm willing to have a discussion, but you know, I'm not necessarily right. These are just my learnings. There's some problems in the wallboard and construction industry. Of course, we focus on interior linings, wallboard and plaster. I'll go into our materials in a minute. But there's a real kind of resource scarcity. Price of gas, of course, is also a bit of a concern for a lot of these materials. There's waste at the end of their life, and how does that waste get treated? And then, of course, this issue around unhealthy buildings, and about how we, you know, in terms of Maslow's hierarchy, we're so bothered about what we put on our skin, what we wear on our second skin, but the fabric that we actually make our buildings from, that we spend 90% of our time in, you know, like, well, that's kind of, it's not even tertiary, is it? You know, for most people. So really trying to understand how we can create materials that connects people back to their third skin, and on an industrial process and for the mainstream market. So reason why, another reason why I guess I'm standing here today is that, you know, Adaptavate has been recognized as a pretty kind of pioneering and an important business in terms of the transition. And that's not blowing smoke up the proverbial. That's just, you know, we've been taken from 3,000 companies in the UK and whittled down into a, this is not paid. I've not paid to be in this. It's all just done through interview and scientific kind of research. And some of the companies, that are featuring here are genuinely able to take gigatons of CO2 out of the atmosphere, and we're really proud to be standing alongside them. And so that's really our focus. And so I guess I'm kind of coming from the hippie undercover into a kind of commercial managing director that wants to affect some serious change, and I'm keen to spread the word of how we can collectively achieve that. Again, obvious caveat, I'm not always right. I might actually be getting some of these slides back, which would be bloody brilliant. Okay, so this report that I just showed you there has basically looked at a bunch of different industries, right, and a bunch of different areas of carbon emissions, and you can see them listed out just here. Can everyone see that everyone's good now? We can see all this and see my arrow and stuff. Great, nodding of heads.
Yeah, we can, Tom. I wonder if in that case you might want to put it in presentation mode instead of the slide. So
it's not wholly done it yet, so I'm just going to keep it like that, if that's okay.
Yeah. Let's not risk it.
Yeah. Okay. Yeah. So the built environment's a big part of it, right? So this report looked at a whole host of different areas, and it looked at the built environment, and the built environment accounts for 21% of global emissions, of CO2 emissions and greenhouse gas emissions. In the UK, it's 17%. Okay, but what it also identified is that of clean tech investment, so that's not of investment, that's of clean tech specifically. That's 14% of total VC investment, right? But of clean tech investment specifically, only 5% of that is going into the built environment. Okay, and so if we were to look at about transitions, then this is a really bloody big problem, but it's quite underfunded. The other area that we operate in is in this kind of industry, manufacturing, and resource management, right? Again, 29% of global emissions, 24% here in the UK, 4.7% of clean tech investment is going into this space. So as a material developer and a industrial process designer, designing the industrial ecosystem of the future, that's a really big challenge, right? Because we operate also in really capital intensive industries. Okay, so it then comes into a sort of, how do you pave the way with this knowledge in mind? One thing is for sure is that we are all becoming, whether if this is at work or at home, with our kids, with our friends down the pub, in our board meetings, in our management meetings, whatever, we're all becoming increasingly conscious about our footprint and what makes up that footprint and how we can optimize that footprint and the effect of that footprint on the world. Where can natural materials play a part in this? Well, what we can see is that we can have a UK perspective, an Adaptavate, a UK founded business funded in part by the UK government, But here, what we're set up a business to do is to have a UK founding, but a global vision. And so accessing global markets through localized production. So on the left here, you can see, okay, we've got these carbon targets. We need to get to net zero in the UK by 2050. And there's a bunch of different ways in which we can do that. What this is to say is it's not like natural materials are just going to solve everything. And we all know that, but I just wanted to state this. This is a kind of joined up systemic rethinking that needs to be had. And quite typically there's some flywheel effect within these different colors on the bar chart, okay? What's also interesting as an MD of a business that has a global aspiration is that when you start to, I know my own backyard pretty well, right? I know the regulation, legislation. I know it's okay. I'm not an expert on anything, but I know it all right. Our team is in various parts. When you start going to new territories, because our business model for some of our products is a licensed business model, so that we can think global, but produce locally, which is really important for biomaterials at scale. You can start to see that some people have got some really ambitious carbon targets and some people kind of aren't. And the big patch in purple, they're otherwise distracted with other stuff at the moment. So how do we collectively move towards business models that can start to collectively achieve some of these targets? So really, what just in terms of a stock check, natural materials in themselves are great. They have part of the solution. Bringing it down from the kind of systemic approach, we can create products that are easy to use and can be used by every specifier and builder. What Adaptavate do is we invent and develop natural material products that can be used by anyone. We ensure they can be made on scalable industrial processes that can hit the mainstream, that can hit price points that the mainstream can handle. Because of course the cost of standard materials are going up, as we know. And so our materials, due to our processes, are going to be able to come down with scale. And then importantly, it's around business models that can deliver this around the world to be able to affect the change. I'm not going to dwell too much on the right hand bubble there, but that's what I like doing is thinking about systemic change, accessing a global market through localized production. Okay, and so if we look at natural materials on their part more specifically, I believe what they have in terms of a benefit is they can bring in, if we're with our approach and with the way in which we set the business model up or with the foundation up, they can be easy to install, they can be healthy for people in buildings and the buildings themselves, and they can capture carbon or certainly reduce carbon to be able to create a flywheel effect on industrial scale to have actually a regenerative material flow. And I'm going to investigate that in a bit more detail moving forward. But what that's also to say is it can be economically profitable and it can be ecologically profitable. And if we set our business models up with that premise, then profit is no longer a dirty word. And that is what we are trying to prove with our approach to the industry. And we believe this creates a positive ecological flywheel. So what are our products? We have two main families. We have the Breathaboard side of our business, which is very much in the latter stages of development. This is a drop-in alternative to standard wallboard. It's to standard gypsum wallboard. We're currently closing an investment round in the next week to build our pilot line that'll be here in Bristol. So I think it'd be lovely to invite the Green Register kind of ecosystem once we're up and running to kind of bring people in to show them what we're doing in terms of our carbon capture processes and training and whatnot in terms of our products. And so we'll be able to produce board on a scale that we haven't been able to do, full-size boards, start of next year. We're commissioning at the end of this year. So that's super exciting times and why I'm probably a little bit worse for wear at the moment. But the product we do have in the market right now is Plaster. And that's been, as I said, been distributed through Eco Merchant. It is 100% natural lime-based plaster. It's been designed by builders for builders. It's easily specified. It uses the same tools, same techniques, same times as all standard gypsum plasters, but you got all the performance benefits of lime. It's a high performance product made easy. Not only is it distributed through independent merchants like Eco Merchant, it's also now starting to be distributed through SIG and Travis Perkins. And so what we're doing is paving a way into the mainstream market here to that main distribution. And we've got two new products coming to market really soon. One is an high insulating plaster that's made to be the best insulating, the blend between best insulating, cost effective and quickest to set, so you can get it on the wall fast and to make it cost effective on site. We can come on to that and how that's important in a bit. So Plaster has been on the market for 4 years or so, and those two new products are coming on in the next few months. So Breathaboard has got a bunch, it's designed to be used and installed in exactly the same way. We take food crop waste. So in the UK, we could use oilseed rape, we can use wheat and barley straw, we can use industrial hemp because it's a wicked plant at absorbing CO2 in terms of carbon capture. We incorporate that stuff into an industrial process that captures carbon from waste emissions from industrial emitters. So co-location in terms of an industrial ecosystem of the future, we can actually reduce the bottom line cost of CO2 emissions, which is of course increasing in cost. And we can funnel that into our curing process as a form of carbon capture and utilization. That goes into a product that's the third most used building material in the world and can go onto anyone's walls installed by anyone. We intend to compete at a price point like fire, acoustic, moisture boards, we'll be able to compete on a price point the same as them, and that's 50% of the wallboard market. 400 million meters squared is produced in the UK alone. It's a pretty big market and growing. And so this product it's lightweight, it's got better acoustic performance, it absorbs CO2, we've got a better thermal performance, and then it's comparable fire and structural rating. It's all been tested to the same standards as gypsum wallboard, and we can actually absorb VOCs. As we were developing this, kind of came apparent to me that if I was going to take on the wallboard industry, it's probably going to take more than 2 or 3 years to actually get something that was at a price point that could be in the market. And so we decided to actually launch like a minimum viable product in kind of startup speak, I guess. It's Plaster. It's got a lot of the value propositions that the board has, but it can be really easily made, really easily certified, and really easily got into the market. And so this has got the same value propositions as our board. It's installed in the same way as standard plaster. It's got quick setting times. It's got all the performance, but it's made easy. And that's doing really well on going through eco-merchant and our other distributors at the moment.
So Tom, we've got 2 questions about the board.
Yep.
So Judith asks whether it's structural and usable as a racking board.
No, the gypsum boards aren't used for racking typically, unless you double board them. We'll be adhering to the BSEN 520, which is that for gypsum plasterboard. If you want racking boards, probably go into OSB, Thermacell, that sort of thing. Or you look at a system that can get you that.
Yeah, so it's replacing gypsum board, isn't it? It's not replacing a racking board. That's not the point of it.
No, well, it's not been this like the initial launch product is not designed to do that.
No. Okay. Isaac says, what's the thermal performance?
Yeah, I mean, to be defined, but we'll be like around 0.1 watts per meter Kelvin.
Sam says, do you have a BBA? I think he says BAA, but I think he means a BBA certification.
No, not on the board, because you need BBA comes on a process. We will have when we launch into the market. That's has kind of part of the presentation actually is certification. But we will absolutely have, BBA. Any territory we go into, we'll have the top mark that you need to go into that market and compete.
Thank you. And Jerry has asked, what's the Breathaboard fire rating? And it says BSEN 13501.
Don't know that one. I don't know that one off the top of my head, so I can't make it up. Our technical director would. Essentially, our board has been developed to the same standard as gypsum board, so we'll be at A2. So that gives you 30 minutes. It's not been designed to be a fire board. But again, going into later parts of the presentation, we have to be really clear about products as part of systems. And so our product has been developed to the same standard as the gypsum wallboard product. And we could optimize the formulation to be able to accentuate any of these kind of performance characteristics that you see on the screen. And so, yeah, I think that gives a flavor of the approach.
Okay, and this question that I've got actually, I was speaking to you, Mark, about a while ago, is that we're doing a refurb with wood fibre internal wall insulation. And time was really very tight. So we were trying to not use lime plaster because of the time it takes. So we had hoped that your Breathaboard would be ready for market. It's not, but that would be a very good application, would it not, for wood fibre as a finish, internal finish?
Yeah, I mean, the setting time of our plaster is the same as gypsum. So it's designed, and I've got some slides on this in terms of all-in costs further on down through the presentation. Great. Because product costs are only 15 to 20% of any project costs. It's the 80% is your labor time. And so we design performance products made easy so that they save you time in comparison to performance products, and they are the same time as standard products, but with the performance uplift.
Thanks.
Cool. Our product can go, Plaster can go on a whole host of different, just touching on Lucy's point there, whole host of different of substrates. We have technical data sheets on all of this stuff and sell wood fiber and wood wallboard systems through eco-merchant and various other merchants. So we're really taking a step into that systems approach. It looks beautiful too, which is nice. It can look really nice as well, which is nice. And my walls are all done in Plaster. Lucy asked me to turn my lights off, so you can't actually see it properly, but Trust me, they're very beautiful. Although I would say that, wouldn't I? So we've done some background stuff. I'm going to whistle through this because I think we're a bit tight on time, given that I was a little bit late with my slides. So here, basically what these slides are saying is the UK GBC have done a great report, and I'll link it into you guys, which is essentially the whole kind of balance between operational energy and embodied energy. And if I were to kind of summarize the thesis, it's essentially due to the energy efficiency of operational energy, proportionally of carbon emissions of the building, any building, operational energy is reducing because we're getting more thermally efficient airtight boxes, and we're getting more energy efficient methods of heating and lighting, etc. So proportionally of the total CO2 emitted for that building, operational energy is decreasing. So therefore the embodied carbon as a percentage of it is increasing. And so what that means is that as an industry, the opportunities for reducing embodied carbon of the fabric of the building is increasing, and the duty of reducing that embodied carbon of the fabric of the building is ever more important, and is only going to increase in importance. And so what the other thing is to say here is that if we go from idea on the back of a fag packet through the Reba stages, not suggesting that Reba stages have been written on the back of a fag packet, but through the Reba stages to post-consumer or post-occupancy, through the whole build process, our opportunity and impact is the greatest at the design phase. But throughout all of those phases, our opportunity for impact reduces. And so it's important to be educated and aware as an industry of our natural materials and how they can affect on that early design phase. But that would have been better illustrated by some pictures. And that's one of them. And that's another one of them.
Okay, I'm going to give you a question now, Tom.
Yeah.
And I think it's one, you know, that comes up when we're doing anything with sort of arable land, and, you know, what do we use it for? Do we use it for food, or do we use it for materials? So Jack, he loves the idea of Breathaboard. His question is about the use of arable land. If the global market of plasterboard was to eventually be replaced with a natural board, what area of land would it require? And then he goes on to say, it seems to me we're trying to feed a growing population, adopt more sustainable farming techniques, rewilding and so on. Do we have enough land?
Yeah, great question. So I don't have an answer to the first question, but I will try and work it out. That's not a question I've ever been asked, but I think it's a great one. I think it's, as with all these things, like specifics aside, it's a transition here. So we won't be going from like not making a board to making the whole of the industry, the whole of the whole $7 billion wallboard industry overnight. What we do is we just built, I'm just about to go into it, we just built LCA tool, life cycle assessment tool, which is a fairly complex, multi-dimensional model that essentially calculates the embodied an EPD, an environmental product declaration, for a board facility anywhere in the world. And that measures, yes, kilograms of CO2 per unit, but it also measures the 30-something other variables, parameters that an LCA or an EPD does, that measures. And one of those is indirect land use change. And so what we do is we use this calculator. So we haven't got a number, we haven't got a calculation verified by BRE. What we've done is we built a tool, built a model, and we got that verified. So what that enables us to do is optimize our products and processes with the 34, 36 parameters of an EPD in mind. That, if we wind back even further, and we can optimize that for any production partner anywhere in the world, okay? If we wind back even further, what I don't want to do is grow crops to put in building materials, because it doesn't make sense. What we need to be able to do is we're going to need to feed our people. Now, when we feed our people, typically the plants that we feed them off, these massive crops, it's only 10 or 20% of the crop that actually gets used to feed folk. there's a whole like 70, 80, 90% of the crop that's actually just either turned back into the soil, which is good, you know, or is a sort of byproduct. And what Adaptavate can do is take that byproduct, which currently has a very low value, or has very low value, and we can valorize that into building materials. Now, there is a transition here. One of the things that we're also looking at is post-consumer fibrous wastes. So whenever we go into a new territory, the first thing we do is a supply chain survey. We look at what crops are grown there. Are they what abundance do they have? How are they going to look like in 10 years' time? What are the post-consumer wastes, fibrous wastes that we could use to be able to blend in with that, and take those variables, control them, and put them into a product that meets that standard in that territory. It's very similar to the chemicals industry and how they take natural feedstocks, characterize them, and put them into mainstream processes to make standardized products. And what we believe with that approach, bearing in mind the business is founded on ecological principles, we do not do things at the expense of the ecological balance, that we can be able to blend that and transition the industry through a blend of these approaches as the industry and the world kind of develops here. So I would say I haven't got all the answers on that front, but I think that's the kind of approach we're taking. I hope that highlights.
Thank you, Tom. That was great.
So then the whole industry is now going for EPDs. Well, give me an APD. What's your EPD? Absolutely. EPDs are great. Life cycle assessments are great, but they're complicated. And at the moment, the industry doesn't actually know what they're looking for. In this call, I think we'll be very educated people in this space, right? But when we go and speak out into the wider industry, this can be less so, let's just say that. When they're actually asking for an EPD, they actually just want to know kilograms of CO2 per unit. They're actually bothered about the 30-something other parameters that they're talking about. So it's complex. Do people even know what they're after? It's typically just one number. So what we've done, as I said, is we've built a tool which enables us to be able to produce an EPD and publish it under whichever house we want to produce under. There's a number of ISO standards and European standards, and they're not all the same. And they're really fast emerging market at the moment. And so, fast emerging scene, landscape. I've spoken about the different parameters measured. It's not just about carbon. It's so much more complex than that. And you can't develop something with only one thing in mind, because then you run the risk, as that question asker was sort of suggesting, well, you're going to just go and grow crops for materials? That doesn't make any sense. So what we've done is built a carbon tool to be able to understand this in deeper detail. And that enables us to be able to optimize products and processes for any place in the world. We need a holistic view, and we need to simplify this. Once we've done all the complexity, we need to simplify this into a so what for the industry. I was with the SIG team, the SIG team the other day, and they were like, biogenic what? You know, and there needs to be a piece around making this accessible for the mainstream market. A year ago, no one knew what an EPD was, or 18 months ago, no one knew what an EPD was. So we can get there, right? It's just about a transition. But as this says on the right, it can't just be about carbon emissions. We need to think about the holistic picture. So we're getting through it all right now. How can natural materials help? Okay, there's a lovely picture of biomaterials here. They are annually renewable. They capture carbon. They're very clever. They photosynthesize. We can then take that carbon, we can lock it into products, and then we've also developed a carbon capture process that we can take from CO2 emissions, and we can combine that waste CO2 that people get charged for, lock it in with plants into mainstream products. Biomaterials make it lighter, make it more thermally efficient. They can restore, when our waste materials at the end of their life, they go back into the ground, adding minerals and nutrients, both organic and inorganic, into the horizon of the soil, and carbon, importantly. What's more is they can be compostable, and they can actually be used to create energy with anaerobic digestion. I'm sure there's some other points on there, but I think I've got them all there. When we look at using biomaterials in material flows, we can actually imagine a situation where instead of taking a finite source, putting it into a high industrial process that emits CO2 and uses energy, puts it into the market and then throws it away, a very linear material flow. What we're doing is proving, and we have proved with the support of Innovate UK and our vision, is taking annually renewable stuff, putting it into carbon absorbing processes that goes into a performance product for the end market. At the end of its life, it can be taken back and put on as a soil conditioner or fertilizer, granulated, that allow carbon back into the soil. Or we can put it into anaerobic digestion. It goes really nicely with food. Food is acidic. Our product is quite alkaline. And those two things produce syngas to be able to produce energy, or CO2 to go back into our process. And that byproduct from anaerobic digestion is a leachate, and that's super nutrient. And that can go back on the crops to be able to grow more stuff. And so instead of it just being a very linear flow, we've completely rethought it and proven it out. And we're in the process of proving this industrially. What this can do is be ecologically regenerative and economically profitable. And therefore, those two things can live very well side by side. And if we're to solve some of the big challenges in the world, we need to have capitalist structures that can fuel ecological regeneration.
So Tom, relating to that, Dermot asks, is the CCS process you refer to part of the production, or is it entailed within the natural material carbon cycle?
Yeah, wicked. So both, like there's and just to be clear, it's not CCS because storage is 100 years plus. This is carbon capture and utilization, which is sub 100 years. So carbon capture and utilization is you capture the carbon, you put it into something useful, utilization. Storage is that you go and put it under the ground, or you put it in oil wells or whatever, chuck it off the sea or whatever whatever the next thing is that they're going to do with it. So, and we need both. It's not just one or the other. We need both to be able to kind of get the graph going down, as we saw earlier. So there's carbon capture through the growing of the plants and then locking that carbon up and put it into the factory. Then there's so many low-grade CO2 emitters around the world. I mean, that's what's given us this problem, right? And so typically those CO2 emitters have a low-grade heat and a high-grade moisture as an emission, and they normally strip all the nasties out because they have to for EA, environmental agency or environmental regulation purposes. And pretty much what we're doing in our pilot plant is working out how and what we need to do from a feed study is by taking those emissions and channeling them into our carbon capture process in our industrial process. Hope that answers that. So when we're looking at this, it has to be thought not just with carbon in mind and not just with bio in mind. It needs to be thought in terms of market uptake. It needs to be health of people that live in the buildings, health of people that install them, ease of specification, and CO2. And of course, all those great points that people have made, just about indirect land use. What about the eutrophication of water? What about, carcinogenic off-gassing, blah, blah, blah. I mean, there's 30 parameters at least that you need to consider when looking at these. And so Adaptavate's real focus, this tool gives us a really great ability to be able to hone the product for a kind of holistic approach. And of course, as we all, I'm sure, know, EPDs are moving just from the A module to the C module. And that's what one of those diagrams actually said that wasn't there, the elusive diagram, gate. Which was, it's now the whole life cycle assessment that we're looking at. So it's not just about carbon that we've got to be mindful of here, it's about health. And so what can natural materials help here? Well, natural materials typically are breathable, certainly ones that we develop, and they can be hygroscopic and they can be thermally insulating. And it's not just about U value, it's about a whole bunch more than that. It's about the ability to decrease temperature of walls, so you reduce the risk of condensation, and of course, asthma costs like 72 billion across euros across Europe. But it's also about like, how do we retrofit I don't know how many it is, you see different figures, like 17 million homes that need retrofitting between now and 2050, insert large number here. We need to retrofit those hard to treat homes, and natural materials can be really helpful in doing that whilst being healthy and achieving our carbon targets. Natural materials can also absorb pollutants, and they can absorb CO2 through their lifetime. And so I've put biomaterials here, but it's synonymous with natural materials. And I mean, I'm happy to get into the debate about natural materials, natural products, healthy products, the difference between materials and products. They all sort of sit under one broad church for me, which is all underpinned by impact, and different strokes for different folks as well. Some people want to be able to do mud buildings and make that really accessible. let's do that, because there are going to be lots of people that want to do that. But let's also think about how we can take natural materials and put them into products to make it easy for people to buy. They can also be, these natural materials, absorbing and desorbing of moisture, and that can reduce the need for mechanical ventilation and internal air regulation. You still need to, strip CO2 and your air. You need to purge it out, of course. But if you think about a fabric first approach, natural materials have the ability to absorb at least 4 times the amount that standard plasters, looking at this, is about. This is data done by the University of Bath on our breather plaster at a certain height of relative humidity, 80% relative humidity, and it's looking at the moisture content in kilograms per meters cubed, which is standard SI for this sort of thing, looking at it in comparison to a bunch of different materials. And so the health impacts we can go into in great detail, and I'm happy to. And we can provide lots of information on that. But I didn't want to do a sales pitch here. It's not about us and our materials. It's about the approach. And so to do that, going back to our cogs that are moving together, they have to be easy to install. Because Dave, Gary, Sally, Sandra, they all have to be able to pick them up on site and be able to install them really easily. And, architects and specifiers need to be able to specify them really easily on site. Excuse me. And that has been the case in lots of projects. And these are quotes by people who do this stuff day in, day out, installing our products, saying it's easy to install. It's amazing what people do when you put a vegan bacon butty in front of them. But going back to positioning into the market, it's okay if they're easy to install, but natural materials are going to cost more, right? Well, yeah, I guess they do. A Porsche does cost more than a Ford Focus. You're buying performance. Your natural, organic, beautiful skincare regime that you seem to be applying every morning, that's more than just Nivea, I guess. There's a price premium to this. You still apply them all in the same way, but you're paying a price premium for that. Is that merino shirt that you're wearing? Oh yeah, that's probably, why aren't you wearing a cotton one? So the same thing is the same for building materials, connecting people back to their third skin. Product price is only a fraction of the all-in installed cost. And our industry we are working with our industry to be able to understand that all-in cost. And so this is just in comparison to a couple of other products on the market with our breather plaster. Standard room, standard labor rate, 2-man gang, some assumptions here, price as per eco merchant at that date. And basically, if you can save on labor, but gain in performance, you're not only getting your embodied carbon down, you're getting your operational carbon down, and you're getting it for labor, all in cost savings as well. And we're working with it. We're working to get better at that. I'll be honest, we're not there yet as a business. But we're trying really hard to help our industry think about how price can be perceived. And that's one thing. Value is the real thing that I think people are coming at. And there's a massive race on for carbon. Of course, that's going to have an increasing cost that we don't know what that's going to be in the future.
So Tom, there's a question about combustibility. So Jack's asking about whether or not Breathaboard is not rated as a non-combustible material, therefore it can't be used in buildings over 18 meters.
I don't think that's the case, although Jack may be right on that. I don't think so, because one of the main things that we're doing at the moment, you might be right, and if so, then I'd love to see that. What we're doing, and it kind of comes onto a slide that I've got coming up in a second, which is about, we do products, we develop products, but we know that the mainstream industry procures systems, and those systems are designed for specific applications in mind. We're not designing a board for 90 minutes fire rating. You design a system for 95 minutes fire rating. And a system is a combination of those products and elements and the way it's installed and detailed that enables you to get that. And so what we're doing, we don't have all the answers. We can't do everything. What we're trying to do is work with the giants that do this and with people like SIG, who are the best systems integrator into the mainstream market. And I've got some slides coming up on this in a minute, but it would be, and Jack, you might be right, mate. I don't know, but what we're trying to do is take an approach about products into systems and systems for specific applications. And Breathaboard might not launch being able to go into the whole addressable market, 100% of the wallboard market, okay? But what Breathaboard will be able to do is target at least 50% of it. And for now, that's better than nothing. We can, over the transitional period, grow into 100% of the market if we get that far, or someone else who takes on the technology or whatever it is. I'm just wearing the shirt for the period of time I can wear it, right? You know, there's problems that larger businesses will be able to solve, and collaborations will be able to solve. But that's our approach at the moment. Okay.
Thanks, Tom.
Comes back to a slide I've got in a minute. So what are the cosmic nuggets here? You know, favorite Adaptavate phrase is like, well, tell me the cosmic nugget. Okay, we've had an hour-long meeting. What's the cosmic nugget, right? It's complex. Well, great, thanks. Yeah, but natural material products can help, right? And I think we've really understood how natural material products can help, not just in terms of a carbon element, but a health, both from us as people in buildings, but also the fabric of the building's health. And how, you know, we can make them, if they're designed in the right way, be easy to use. But I think if we start to look at recommendations here, I think it's about, as we transition from being natural materials as a sort of niche area and trying to grow them into the mainstream, I think we need to sort of think about growing the pie, and about, you know, we've got a big slice of a small pie in natural materials, but we really, to have impact, we need to kind of grow that pie. And I think to do that, at the moment, natural materials have been right down here, if you like to think in triangles. So this is the volume of the market. And up here, you've got tier one contractors and all your big mainstream stuff, procuring systems, you know, like Jack was sort of saying there. You then got your sort of large to small contractors and developers, and then you've kind of got your domestic market. And that there's some, I agree, there's some haze in between those guys, but you can sort of see where I'm getting. If this is the volume of the market, then the number you need to talk to be able to sell into that or specify into that market is the inversion of that, right? There's only one procurement manager for wallboard at SIG or ISG or Lang O'Rourke, right? And they sell millions of this stuff. Mr. and Mrs. Jones want 30 square meters. There's millions of Mr. and Mrs. Joneses, or Dave and Sharon's, you know, dry lining, gig. So what we're trying to do is trying to understand about how we get green materials, natural materials, however you want to kind of term that, and we're growing that. So it's not about preaching to the choir, although look at me standing up here on a Monday evening to the choir. I recognize that. But it's about growing the choir. And that is the world record, Guinness World Record, largest choir in the world, which I thought was pretty cool. And that comes from growing the choir, but also increasing awareness throughout it. Going back to what Jack said, you know, about, okay, so let's just assume, and it's a high likelihood that Jack might be right, okay? And we can't go to buildings over 18 meters. Okay, that's a wicked piece of news. Thank you. That means that we aren't going to bother with that bit of the market, okay? What it does mean is that we're going to go and look for everything that's outside of that, okay? And so this whole scale transition, when you're taking a systemic approach, all you're doing is just solving problems to be able to find where your strengths are. And so, you know, where might the strengths from natural materials be? Well, they're probably in retrofit, really hard to treat, in healthy buildings, you know, and in a growing market that's looking for carbon reduction. You know, I stand in front of, have meetings with, you know, some of the country's largest procurement, you know, procurement managers for some of the largest companies in the country, saying, we need this solution. We need your board. We need your systems. We're working with SIG to be able to get them to you. We've got to run, walk, you know, walk, crawl, walk, run. My 1-year-old is doing it at the moment. I should be able to know the sequence. You know, chop wood, carry water. Transitions happen over time. And so know where your strengths are so you can go and play in there. So to do this, to get natural materials into the mainstream market, we're getting there, guys, which is about easily productized products, okay? Make them easy for people to use, okay? Make sure that that arrow can go up into the triangle, but make sure that we're not doing it for ecological trade-offs. And that's where our EPD tool enables us to lead in this space. And that is so important to me as a founder and as a managing director. And that is our main focus moving forward. It needs to be easy to use and specify. We need to have business models that are designed with economic and ecological profit. And those two things can go side by side if it's set up in the right way. That's when real impact can be made. We need to have tried and tested systems tried and tested products as part of systems that the mainstream market can procure with trust, with confidence, with the right certification and the right warranty. And that's what we're working with these companies to do. And that falls on our shoulders squarely. Have a clear, independently tested performance and durability claims, as has been highlighted by the questions, and readily recognizable certification to build markets trust. If we can do this, and it's a transition, it's not going to happen overnight. These things take time. We need to accelerate the pace at which we're going, because you can see that we're running out of time. 2050 ain't that long away. 2030, when everyone's going to be carbon neutral here, is not that long away. It's 2022. And so we believe that if we set these things up, natural materials can help achieve our net zero goals. And they can do more than that. They can create healthy, high well-being buildings and people within them that are low carbon and energy efficient, that address both operational and embodied carbon, that anyone can use. And if we do that, then I think we've got part of the puzzle that we need to be able to drive towards our targets that we're putting in place. Thanks.
Perfectly timed. Thank you very much, Tom. We've had a lot of really excellent questions. We've got a couple more minutes if anybody wants to just unmute themselves and ask Tom any questions. We'll send you a transcript of all the questions. We'll send you the presentation and the recording, and we'll also send you a feedback form. So I'm sure that Tom would like to hear the feedback. So please do try and respond to that. You're getting a lot of thank yous, Tom. I think people are probably going off for their supper. I thoroughly enjoyed that. Thank you very much. Actually, Sam's just raised his hand. Do go ahead, Sam.
Hi, Tom. Thanks for a great presentation.
Hi, Sam.
Tom, I'm a bit of a tech geek. I'm interested to just know exactly what your plaster is made up of, and what gives it the properties that it's got.
Yeah, sure. So our breather plaster that's currently on the market incorporates a lime-based binder with various bits of lime in there, a blend.
Is that quick lime or NHL?
It's a blend, so it's not quick lime. That's challenging on site, on standard sites, but it's a blend of hydrated and a little bit of NHLs, and we use pozzolans as well to be able to get the quick set within the times that we want to be able to be like gypsum. And then we also incorporate, I don't think we had that picture to be honest with you, mate, but there's some lovely biomaterial that's going through one of my colleagues, Owen's hands. He's got lovely hands. We incorporate so industrial hemp particles. I'll give you a cool fact. The Queen sleeps on a bed of hemp. Hemp fiber grown in Yorkshire is grown in Yorkshire and processed by Harrison Spinks. They take the fiber, they weave it into mattresses, and then they make the springs, and they make everything in there in Tadcaster. And we take their waste, all that sort of super small sub 1 mil particles of industrial hemp dust. We put it in our plaster. So that's our breather plaster products. We've got a top coat, which is a lime-based plaster, which will be the same finish as gypsum, super smooth but faster, installed faster than gypsum. And then thirdly, we've got our insulating plaster that's coming to market in the next few months. That's for solid wall application. And that is a blend of lime and super lightweight aggregate perlite, including perlite. And that's got a setting time of around 2 hours. So that means you can put 40 mil on, go for a, do whatever, fag and a brew, typically plasterers, haven't been one myself, and then come back and put another 40 mil on, and you can keep doing that, or you could just top it out with one of our other coats, top coat or breather plaster. But get in touch. So if you've got any direct questions, not to get into sort of too much detail today, any questions, my contact details are available. Get in touch with on our team, our website. There's information on there. We are looking for projects for the insulating plaster and the top coat. That's going to be launching in the next couple of months. And just to also mention, our pilot line will be up and running by the end of the year. So we are looking for pilot projects for the board. We are already inundated with that. We kind of sold what we can make already, but we'd be love to talk to people about future projects.
Great, Sam. I hope that's answered your question.
Yeah, thank you.
And Sam will really look. Tom will really look forward to when we can have that site visit when you're up and running.
Yeah, I reckon early 2023 or late 2022, depends on how the commissioning goes. But yeah, we'll be in sort of in the Bristol area. We'd love to get people down there and do some training on the plasters. You can look at what we're doing. Great.
That would be fantastic. Okay, guys. Well, go and have your supper. Lovely to see you all. Come and see us for another event soon. We've got so many on the website. But thanks very much to Tom. Tom, if you want to hang around just for a couple of minutes, we'll put everybody in the waiting room.
Yeah, no worries. Thanks ever so much. Reach out directly if anyone has any direct questions. Love to connect.